Hello, folks. This video is hopefully going to be a pretty short one. We're just going to talk a little bit about the connection between hypothesis tests and confidence intervals now that we've learned about both. And then I'm going to tell you a little bit more about power, right? What power is, statistical power, and how that connects to errors, right? Our type 1 and our type 2 errors. Okay, so really quickly, very brief, okay? Hypothesis tests versus confidence intervals, right? They're both very useful inference tools, right? Hypothesis tests, though, only tell us whether or not to reject a null hypothesis, right? If we end up rejecting the null hypothesis, then we end up wondering what that true value might actually be, right? What is the population proportion, right? If we know it's not what the original claim was, we know that it's less than that, or maybe more than that, or perhaps just not equal to whatever that claim is, right? All we know is that alternative hypothesis, right? That's the only conclusion we can reach. So what confidence intervals are helpful for is to be able to give us an idea of what that proportion could be, right? Because because confidence intervals give you a plausible range of values for your true value, okay? Another important connection between hypothesis tests and confidence intervals is when you're looking at a two-sided test at a particular significance level, so say alpha is 0.05, okay, that will give you about the same amount of information as a 1 minus alpha percent confidence interval, right? So like a hypothesis test where alpha is 0.05 will give you similar information to a 95% confidence interval, right? They're going to tell you similar things about the population parameter, okay? So there's just a couple of connections between hypothesis tests and confidence intervals. Very rarely does this show up on like a free response type question, but I've seen multiple choice questions every once in a while that deal with this idea, all right? But with that, let's jump into like the bulk of this video, which is talking about statistical power, okay? So when you run a significance test, right, a hypothesis test, right, like I told you in the previous video in this section, it's always possible that you get something wrong, right? So just as a reminder for you, a type 2 error occurs when you fail to reject the null, but that null is actually false. Like it should be rejected, but our test tells us not to reject it, okay? Now, we have the ability to calculate the probability of a type 1 error, which I talked about in the last video. The probability of a type 1 error is your alpha value. Okay? The probability of calculating a type 2 error, like calculating that probability, depends on a lot of different things. It's not something you would have to calculate. That goes beyond the scope of this course because this is an introductory statistics course, okay? But the reason we want to talk about type 2 error is because it's directly connected to this idea of statistical power, okay? So if you have a high probability of type 2 error, what that means is that your test, so the significance test or the hypothesis test, is not sensitive enough to detect alternative values. Okay, basically, it's just that your test is not strong enough. Okay, the symbol that we use for type 2 error, if type 1 error is alpha, type 2 error is beta. So it's a capital B with a little tail on the end. Okay, so now how this connects to the idea of statistical power, okay, power is the probability that a test will reject the null, so reject H naught at a chosen significance level. So that's your alpha value. Oh my gosh, sorry folks. Every single time I have to type in alpha, I have to switch over to my my equation editor here. Okay, so power is the probability that your test will reject the null at whatever significance level you chose when the alternative hypothesis, so when HA is true. Okay, so essentially what power is, that it's the probability that you reject the null when you are supposed to. Okay, and the way we calculate power, which again, you likely will not have to calculate, the understanding of power is more theoretical. It's not something you would really ever be asked to calculate. And if they did ask you to calculate, they would tell you what beta was. So your general formula for calculating power is it's 1 minus your, not alpha value, oh my goodness. Hold on 1 second. Oh no! It erased my text. I didn't want it to do that. Some craziness. Okay. Oh, and I need to zoom in a little bit more. Zoom in just a smidge. This is easier for you all to see. Okay, so power is 1 minus beta, right? Or 1 minus the probability of a type 2 error. Okay, so if you want to increase your power, you need to lower your probability of a type 2 error. Okay, so low type 2 error means high power. Okay, your significance level, your alpha, is the opposite of that, right? Your significance level is the probability of a type 1 error, right? So that's the chance that you reach the wrong conclusion, right? That you end up rejecting the null when in fact you shouldn't, because the null is true. Okay, so I want to kind of walk you through visually here in a second the different ways that you can increase the power of a test, right? But one other thing I wanted to show you before I did that is this little table right here, okay, which is similar to the table that we saw in the other video in this section when I first talked to you about type 1 and type 2 error, right? Where you have, if you accept not accept, right? This really shouldn't say accept. It should say fail to reject. If you fail to reject your null when the null is true, that's the correct decision, right? The decision that you make matches the reality of the situation, right? So that correct decision is like your confidence level, okay? If you reject the null when the null is actually true, that is your type 1 error, okay? The other correct decision that you could make is if your test rejects the null when the null is false, right? So reject the null when you're supposed to reject the null. That is your power. That is the power of your test, okay? And the type 2 error, right, is when that doesn't happen, when you make the wrong decision there. So if the null is false, but you fail to reject it, right? You say, I'm gonna keep it for now, right? That's your type 2 error. So if you want to lower, right, your type 2 error, right, you have to increase your power, right? So power goes up when type 2 error goes down, right? Because they're directly related. As power is 1 minus beta and type 2 error is beta, right? Then you have a similar idea with your type 1 error and your confidence level, right? So if you want a higher confidence level, you have to lower your alpha value, your significance level, right? Because again, those are directly connected. Confidence level is 1 minus your alpha, right? And your type 1 error is your alpha, okay? So I kind of want to walk you through briefly a visual, okay, of different ways that we can increase the power of a test, okay? So what you see on the screen right here is like a probability distribution where you have the null is true, right? And then you have your cutoff value here, right? That's your like your probability line, right? So if you go past that, then you're going to reject the null, right? But everywhere else you would fail to reject the null, right? So this, right, the probability that you reject the null when the null is actually true is your type 1 error, okay? Your type 2 error occurs on the other side, right? And then your power is here, right? When you reject the null when the null is false, okay? Right? So power is probability that you correctly reject the null when it's wrong, okay? So what would happen if we increased our alpha value, which again, maybe if this is going to cooperate with me, is this, right? It's this vertical line. It's your alpha value, right? So we're going to increase that alpha value, right? Making this area larger, right? So you can see what happens there when I increase my alpha, my type 2 error decreases, right? Which we talked about in the previous video, right? You can either have like a type 1 or a type 2 error. You have to choose as the statistician, which one do you think is worse? And you try to minimize the one that you think is worse in the whatever the context of your problem is, because they're directly connected, right? The higher your chance of a type 1 error, the lower your chance of a type 2 error, right? So if we're going to lower our type 2 error, then that means our power will increase because those are also directly connected, right? So if we increase alpha, if we increase alpha, the power is going to increase also, okay? All right, so here's another scenario for you. What happens if we increase the sample size? Well, what happens to our distribution is the standard deviation is going to get smaller. So it looks a little bit more like that, right? Same thing happens down here if you have your reality, right? Your true versus false HO. Okay, so what happened to the power, right, is it looked like the power increased, right? You have more area for your power and your type 2 error got smaller, okay? Right, so another way to increase your power is to increase your sample size, right? Which decreases your standard deviation, okay? One more scenario here. Okay, so what if the true value was further away from our accepted or our claimed value, right? So that would be like something like this, right? So it reduces our type 2 error and increases our power. Okay, so that's another way that power increases. If the difference between, say, like your sample value and your true value, your claim, is really, really large, okay, right? It's all a balancing act, basically, is what I'm trying to say with all of these visuals, right? So you have to decide for yourself what's most important in the context of the problem, right? Would you rather, right, if you had to choose, would you rather commit a or have a type 1 error happen, or would you rather a type 2 error happen, right? Which one is worse, right? So you'll have to set your significance level based on which of those you think is going to be worse in the context of the problem, right? So which one is going to be more costly, which one is going to be more dangerous, right, in the context of the problem, okay? Oftentimes you'll see like business scenarios, right, where one of the errors you could make would cost a lot of money, right? You'll also see problems where you're dealing with like a vaccine or a medicine or a drug trial of some kind, right? And a type 1 or a type 2 error, depending on the context of the problem, could be really dangerous for people. Like people could get really sick or die, right? So you have to be able to make that choice as the statistician, okay? So quick summary for you, and this is what kind of goes in your notes here, okay? You can increase the power of a test by doing the following. You can increase the sample size, okay? You can decrease your variation. So i.e. like your standard deviation. Okay. You can increase the difference between the null and the alternative, right? That one doesn't happen as often. And then the last way, which is the way that you have the most control over, right, as the statistician, is to increase your alpha, right, which is your significance level, right, or i.e. the probability of a type 1 error. Okay, so the things that you have the most control over as the statistician when you're designing the experiments are this, right, increasing your alpha, because you get to set that as the statistician, and this, increasing your sample size, right? That's what you have the most control over. Okay, so with that, I want to show you an example of like how a problem might show up that deals with this idea, right, of power and significance levels and error and all of that. We're going to kind of pull it all together here. Okay, so in one of the problems that we did when we were talking about hypothesis tests was the American Idol singers. Remember those TV shows where they thought, oh, there may be some advantage to going last, right? So as TV show producers, right, they are going to make a decision based on the results of your statistical test, right? If there is an advantage to going last, then they want to do something about that, right? Take measures to minimize that from week to week, right? So like switch up the order of people, right? That you can't have the same person being the last performance like 2 or 3 weeks in a row, right? You'd want to switch that around, okay? But if the test says that it's not a problem, then they're just going to continue with what they're already doing, right? Because it's a system that's already in place. Why would I change it if there's nothing wrong with it? Okay, so the question is, in this setting, is it more serious to make a type 1 error or a type 2 error? Right? So let's talk about that first. So you can kind of see it written out on the left side of the screen, but I'm also going to type it out for you here on the right side of the screen. Okay, so a type 1 error here is going to occur if you reject the null when the null is actually true, like in reality. Okay, so the consequence of this is if I'm going to reject the null, then that means I'm going with the alternative, which means that producers think that there actually is an advantage to going last, right? So producers think there is an advantage to going last when in reality, there's not. Okay, so if they think there's an advantage to going last, they're going to make a decision based on that premise, right? So they're going to take measures to minimize the advantage, right? So producers take measures to minimize the advantage. Okay, so that would be a type 1 error. Type 2 error would be if you fail to reject the null when the null is false. Okay, so you're going to keep your null hypothesis when in reality, the null is actually false, meaning that the alternative is true, right? So if we're saying we're going to go with the null hypothesis, that means the producers think there is no advantage to going last, when in reality, there is an advantage. Okay, so if they think there's no advantage, then they're going to continue with their regularly scheduled programming, right? So the producers are going to do nothing. Okay, so in the context of this problem, I personally would say that a type 2 error is more serious in this case, right? Because it kind of undermines the the voting process, right? And could undermine the fans' like faith in the voting process, right? If you take steps to minimize an advantage that's not there, that's not as big of an issue, right? So because type 2 is more serious, so I'm going to go with my gut that says the type 2 error is more serious in this case. Okay. And why? Well, it's more serious because it could affect the outcome of the show, right? It could affect or influence the outcome of the show and like the votes. And how people vote. Okay, so if type 2 is more serious, I need to minimize this, right? We need to minimize type 2 error as much as possible, okay? So going down to our little 2x2 chart here, if I want to minimize type 2 error, I need to increase my power, okay? Right? Do this by increasing power, right? So I need to go to my ways that I could increase power, right? They've already done the experiment, right? So I can't really affect the sample size or the variation, but I can affect the significance level, right? So if I want to increase power, I need to increase my significance level, right? So if I'm going to choose one of these alpha values, I'm going to choose the highest possible alpha value, which of the ones given to me is 0.10. Okay. So key thing here is if you're increasing power, you can do that by increasing your alpha value. Okay, right? And then part B is not necessarily in the context of this problem, right? It's just in general, right? So which would these increase or decrease the power of the test, right? So if we started at 0.05 and we increase the significance level, okay, so if you increase alpha, that increases power because higher alpha, which is the probability of a type 1 error, lowers the probability of a type 2 error, thus increasing power. Okay, so all of these things are connected, right? Okay, and then this one says taking a random sample of 300 people instead of 600 people. So we're decreasing the sample size. That is going to decrease power because a smaller sample size means larger variation. And larger variation, right, is not good for power, right? We want a smaller amount of variation, a smaller standard deviation in order to increase the power of our test, okay? All right, y'all, so that is it for this video, and that's it for this section. So I'll see you all in the next video, in the next section, which is the last section of this unit. Bye, everybody.